Okay, this is the P3 paper from June 2023. It's question number 3. This is both differentiation and integration. We're going to be differentiating trig functions. We're going to be integrating using the reverse chain rule. So let's make a start. So 3 part 1 says, can we find the differential of log of sine squared 3x? So a very big believer in being able to do the chain rule without writing too much down. But let's have a look at this one. If we've got y equals the log of sine squared 3x. So if you want to write this just to help you, not necessarily write it down like this, but as that in your mind, if nothing else to be thinking about it, it's the log of that squared when we're trying to do it then. Let's do the chain rule, as I say, without writing too much down. The chain rule is differentiate the function in the way that you would differentiate it. So in this case, the differential of log is 1 over x. So it's going to be 1 over sine squared 3x, but then times by the differential of this thing here. So the differential of this thing here, which is why I've written it in the brackets, the differential of something squared is 2 lots of the something multiplied by the differential of what's in there now. And the differential of sine 3x is 3 cos 3x. So I've assumed quite a high level of differentiation skills from you to be able to do this one. Otherwise, really what you need to do is go back and do some more work on your differentiation before you get to an exam question like this. Tidying this all up then, well, one of those signs is going to go one of those signs there. So what we'll actually end up with is 6 cos 3x all over sine 3x, and then that's cos over sine is cot, so it's 6 cot 3x there being the actual final answer. As I say, yeah, assuming quite a bit of differentiation skill to be able to do that. Part 2, part A at least, says find the differential of y equals 3x squared minus 4 to the 6 so that we can then use that to integrate, and we'll be using the reverse chain rule when we're doing that. So 2 part A, I'm going to use exactly the same idea. What have we got? So 2 part A, we've got y equals 3x squared minus 4 all to the power of 6, and using the chain rule then would say, okay, dy by dx is, this is something to the power of 6. So the differential of something to the power of 6 is 6 lots of that something to the power of 5, multiplied by the power, take 1 off the power, but then it's always multiplied by the differential of what's in there. And in this case, the differential of what's in there is going to be 6x, which then gives me 36x 3x squared minus 4 all to the power of 5. So that's nice. That's part A done. Part B then, let's go back and have a look at it. Part B says, can we integrate x 3x squared minus 4 to the power of 5? So look, what we know over here that the integral of 36x would give us that function there. So we can use all the information we've done so far to say, okay, if I want, let's write it out, the integral between root 2 and 0 of x 3x squared minus 4 to the power of 5 dx. Well, I think then that the integral of that is 3x squared minus 4 all to the power of 6, but actually it wouldn't. That would be 36 lots of it, so it's the 1 over 36 to take that. So they're leading you through the reverse chain rule in order to be able to do this particular question. We're doing that between root 2 and 0, and it's just a matter of putting all the values in. Just take a little bit of time over it. So that's 1 over 36, 3 lots of root 2 squared. Well, root 2 squared is just going to be 2, isn't it? So 3 lots of 2 minus 4 all to the power of 6 minus, and then putting 0 in is going to give me 3 lots of 0 minus 4 again all to the power of 6 there. You can do that on the calculator. You can do it in your head if you want to. That's 1 over 36, lots of, this is 2 to the 6 minus 4 to the 6 there. So that's going to work out to be minus 112 if you actually go through and calculate all of that. So as I say, assumed a certain level of differentiation skills that if you're not sure of, go back, do some more work on the chapter reviews and everything so that you feel happy using the chain rule and then using the reverse chain rule in that fashion. Okay, hopefully all of that makes sense to you.